Welcome. Today we're going to be looking at some trigonometrical proofs, and this question right here says prove the following trig identity. We need to prove that sec x plus 1 over tan x is equal to sine x over 1 minus cos x. So let's go about doing that. So when you're doing a trig proof, you want to prove that your left hand side equal to your right hand side. All right, so let us start with our left hand side. So LHS just means left hand side. So our left hand side in this case is equal to sec x plus 1 in the numerator, sec x plus 1, and that is being divided by the tan of x, or the tangent of x. All right. Now, we need to show that it's going to be equal to that right there. So we're going to convert sec x and tan x. We need to write them in terms of sine and cos. Looking at what you want, that's how you know how to approach the question. So sec x, remember, sec x is 1 over the cosine of x. Sec x is 1 over cos x. So we get 1 over cos x plus 1, and that is being divided by tan of x. But what is tan x? Tan x is the sine of x divided by the cosine of x. That is the tan of x. Now, what else do we know? We know how to write this as one fraction, right? Now, this one right here, 1 can be rewritten as this one right here, plus 1. We're going to rewrite this one as cosine x over cosine x. Cosine x over cosine x. We're going to rewrite that as cos x over cos x. All right? Yeah, because that's still 1. Because 1 is equal to anything over anything, right? 1 is a over a, right? In this case, a is cos x. Cos x over cos x is 1. So we rewrite the 1 as cos x over cos x. Doing that, what that allows us to do is add the numerators together. So it allows us to know to add the numerators together, and that becomes 1 plus cos x, 1 plus cos x, and then this is all going to be divided by cos x, because when you're adding two fractions, you add the numerator together. So we get 1 plus cos x over cos x, and it is divided by sine x over cos x. So we can write the division sign right here, that is being divided by the sine of x over cos x. Now we know that when you're dividing, we know that we should reciprocate and change the division sign to multiplication. So what this is going to become is we're going to change the division sign to multiplication and reciprocate. So that becomes 1 plus cos x, 1 plus cos x divided by cos x, 1 plus cos x divided by cos x, and then we change the division sign to multiplication and reciprocate. So we reciprocate it and we get cosine x over the sine of x. Now look what happened now. When we at this stage, the cosine x is going to cancel the cosine x from this side. So what we are left back with now is 1 plus cos x over sin x. We're left back with 1 plus cos x over sin x. Too easy, man, too easy. 1 plus cos x over sin x. Now after we get 1 plus cos x over sin x, now we don't get our answer yet. We're nowhere near our answer. Our answer should be sin x over 1 minus cos x. So what can we do to get sin x over 1 minus cos x? Well, looking at this, look what we're going to do. We're going to multiply the numerator and the denominator by 1 minus cos x. And you might say, why? Because look, if I multiply the numerator and the denominator by 1 minus cos x, I'm not troubling anything, because 1 minus cos x over 1 minus cos x is 1. Now, 1 minus cos x multiplied by 1 plus cos x, that becomes a difference of 2 squared. And so 1 plus cos x times 1 minus cos x works out to be, this is the difference of 2 squared, a plus b times a minus b. So now it's a squared, which is 1 squared, minus cos squared x. So we get 1 minus cos squared x over 1 minus cos squared x over sin x times 1 minus cos x. So this is what we get. But guess what now? Now in this numerator now, 1 minus cos square is what? Sin square x. 1 minus cos square is sin square x. Yeah, that's sin square x over sin x, sin square x over sin x times 1 minus cos x. Now guess what? Now a sin square over sin x, because we have sin square in the numerator, a sine will cancel out. A sin square can be broken up as sin x times sin x. So a sine will cancel out a sine from here. And so what we're left back with is sin x over 1 minus cos x. So this becomes sin x over 1 minus cos x, which is your right hand side. All right, let's need a little more space to write 1 minus cos x. But this is how we prove this question. Easy, soft. All right, that's your right hand side, which is your right side. Easy. So that's how we prove this question. All we had to do was rewrite sec x as 1 over cos x, rewrite 1 as cos x over cos x, rewrite tan x as sin x over cos x, do our division, then we had to multiply by 1 minus cos x over 1 minus cos x, and it works out. Easy, soft. Let's look at the next proof question. This question says, prove that cot square x minus cos square x is equal to cos square x cot square x. So prove that cot square x minus cos square x is equal to cos square cot square. So no worries, let us prove this. So again, we know that we always start with our left-hand side. So starting with our left-hand side is equivalent to cot square x minus cos square x. Now, the first thing we need to remember is that cot square x cot square x is equal to cos square x over sine square x. Cot square x is cos square x over sine square x. So cos square x over sine square x minus cos square x. And this is cos square x over 1. So now, of course, we just need to write this as one fraction. So we do our LCM thing like we're in prep school. So our LCM, we know that it is sine square x. Then sine square into sine square goes one time. So that works out to just be cos square x right here. This is now cos square x minus, now 1 into sine square, 1 into sine square goes sine square. So sine square times cos square is just sine square cos square. So we get sine square x cos square x. Good. Now when you have this now, we notice that, look at this. We have cos square here, and we have cos square here. So all we can do is we can factor out cos square from the numerator. So we're going to factor out cos square x from the numerator. And what we're left back with is cos square from cos square leave 1 minus cos square from sine square cos square leave sine square. So we get cos square times 1 minus sine square. And this is being divided by sine square. But now look how I'm going to rewrite the division. Instead of putting it as all being divided by sine square, I put the cos square x being divided by the sine square x. And I'm going to put this part over here being divided by 1. Now look at this. Cos square over sine square. Cos square over sine square is cot. Cos square over sine square is cot square. This becomes cot square x. And then 1 minus sine square is cos square. So this part is cos square. So we get cos square, cot square times cos square, which we know that is just the right hand side. Easy proof, soft, nice. That's how proof part B. All right, let's look at this proof right here. It says we have cos theta over 1 plus sine theta minus 1 minus sine theta over cos theta. Show that this is equal to 0. So to do this proof, we always start with our left-hand side again. So we start with our left-hand side, and our left-hand side is equal to, our left-hand side is cos theta. Left-hand side is cos theta over 1 plus sine theta. Cos theta over 1 plus sine theta minus 1 minus sine theta over cos theta. So now what we're going to get is this right here. We need to write this as one fraction. So of course, we're going to find our LCM. The LCM of the two is going to be 1 plus sine theta times cos theta. 1 plus sine theta multiplied by cosine of theta. That is our LCM. Then we're going to say 1 plus sine theta into this denominator leaves cos theta, but cos theta times cos theta is cos square theta. That becomes cos square theta. Then cos theta into this denominator leave 1 plus sine theta. So we get minus, in bracket, 1 minus sine theta times 1 plus sine theta. 1 minus sine theta times 1 plus sine theta. 1 plus sine theta. Now, when you get that now, that works out to be equal to cos square theta in the numerator. But we have to remember that 1 minus sine theta times 1 plus cos. 1 minus sine theta times 1 plus sine theta is a difference of 2 squared. So that works out to be equal to 1 minus sine square theta. That works out to be equal to 1 minus sine square theta. Now look at this now. Now, just write back your denominator for now. Don't stress about the denominator. So we have our 1 plus sine theta. That is being multiplied by our cosine of theta. So good so far. That is being multiplied by our cosine theta. Now, 1 minus sine square, 1 minus sine square is cos square. So we can rewrite 1 minus sine square as cos square. So this is going to become cos square theta minus cos square theta, because 1 minus sine square is cos square. So we get cos square theta minus cos square theta being divided by our denominator of 1 plus sine theta times cos theta being divided by 1 plus sine theta multiplied by the cosine of theta. That is what we get. Now cos square theta minus cos square theta, that is 0. That works out to be 0. Because once the numerator is 0, then the whole thing is 0. So that's how we just get 0. So this is how we prove this question. Nice and easy, soft. This is equal to now our right-hand side. Easy, soft. Soft, the capital T. Soft. All right, let's look at the next one here. A plus B is equal to tan A plus tan B over 1 minus tan A tan B. So to do this proof, again, we start from our left-hand side. So we're going to start from our left-hand side, and our left-hand side is the tan of A plus B. Tan of A plus B. Now, of course, everybody knows that the tan is sine over cos. Tan is sine over cos. Tan is sine over cos. So what we get is the sine of A plus B, and this is being divided by the cos of A plus B. This is divided now by the cos of A plus B. That's the sine of A plus B divided by the cos of A plus B. Now look at this now. Sine of A plus B over the cos of A plus B. But what is sine A plus B? Sine A plus B, let's write it out. The sine of A plus B is going to be sine A. Sine of A plus B is sine A times the cos of B plus the cos of A times the sine of B. That is sine A plus B using our compound angle formula. Then you're going to ask now, what is the cos of A plus B? The cos of A plus B, as we should know it, the cos of A plus B is cos A times the cosine of B minus the sine of A times the sine of B. So that's what we get. Now, when you get to this stage, you're going to wonder, so what are we supposed to do now? What we're going to do now is we're going to multiply both sides by 1 divided by the cos of A times the cos of B. We're going to multiply both sides by 1 over cos A, cos B. We're going to multiply both sides by 1 over cos A, cos B. And then let's just take a look at what is going to happen. And you might wonder, sir, how do you know that this is what you're supposed to multiply by? How do you generate that quickly? Now, this is what gave me an indicator 1. The only way I could get 1 right here is if I divide cos A cos B by cos A cos B. So we're just going to do it to everything. So again, I looked at what I want to get. I want to get a 1 in the denominator right here. So I need to divide cos A cos B right here by cos A cos B. So let's do our division. So doing our division, this is now equal to, so now we're going to get, we're dividing each term by cos A cos B. So it's going to become sine A cos B plus cos A sine B, and these two are being divided, of course, by cos A cos B, and this is also divided by cos A cos B. This is for the numerator division. This is dividing the numerator. Then for the denominator division now, doing the denominator division now, it's going to be cos A cos B. So we have cos A cos B minus sine A sine B, and that's also being divided by cos A cos B. This is also being divided by cos A cos B. All right, so only thing left for us to do now is our simplification step. Now let's simplify this statement now. Now look at this now. The cos of B over the cos of B, this part cancel. Cos B over cos B cancel. The cos of A over the cos of A cancel. Let's see, cos A over cos A cancel. Cos B over cos B cancel, which leaves just 1. And then sine A over cos A is tan A. So this part, sine A over cos A, we know that that is tan A. So I get tangent of A plus what happens next. Now sine B over cos B is tan B. So we get the tangent of B. That's tan A plus tan B. And this is all being divided by, now look at this now. This we divide by this, we just got 1 anyways, minus sine A over cos A is tan A. That part is tan A. Let me put a bracket around it. This part, the sine of A over the cos of A is tan A. Then the sine of B over the cos of B is tan B. Voila, we get our tan proof. This is equivalent to our right-hand side. No issues at all. Nice and easy, soft. So there it is. That's how we do this easy proof. Too easy, soft. So there you go. Tan of A plus B. Completed it. That's the proof for this question. Nice and easy, soft.